What's up, guys? Welcome back to GGTutoring. My name's Will. I'm just happy to be here to introduce myself. I'm your guys' second co-host. The other co-host is Varun. But I'm ready to be with you guys throughout this first semester of the 2023 to 2024 school year. Let's go.
Today we're going to be discussing ozonolysis. So I'll just write this out for you guys. So, ozonolysis. So basically what ozonolysis is, it's just the breakage of an alkene by an ozone molecule to produce carbonyls. Alright, so there's two subreactions of ozonolysis. So I will draw those out for you. So they're both two steps, and both of them, the first step involves the ozone, but this is where it kind of differs. So you could either react with a reductant like dimethyl sulfide, or you can react with an oxidant like hydrogen peroxide. So both these reactions will both get you a ketone. This is where it differs. So the second reducing step causes the formation of an aldehyde, and the second step, oxidizing reaction, causes the formation of a carboxylic acid. Alright, so that's just kind of a general overview of ozonolysis. But now I'm going to go into like the electron pushing mechanism of ozonolysis. Just mainly the first step, because really in your first semester of organic chemistry, they only cover this first step mechanism of ozonolysis, as the second step of ozonolysis is quite complex. So we're going to start out with our alkene here. Just going to draw identical from the one above, and then we'll also have our ozone molecule. Alright, and don't forget the formal charges. So this is positive, and then this is negative formal charge. So basically what happens here is the electrons from this pi bond will come over here and attack this neutral oxygen, and then electrons from the lone pair on this negatively charged oxygen will attack one of these carbons, and electrons from this pi bond will go to the positively charged oxygen. So this causes the formation of a molecule that's like cyclo in character, as you'll see as I draw it out. So you'll see this shape here is kind of familiar, or it looks like the same structure of a cyclopentane, which kind of is like a 5-cornered structure here. And you'll see So basically this ozone molecule just hopped on top of this alkene here. As you'll see, like, this sigma bond between these two carbons here is still intact here, and the relative position of these groups is not changed. So basically from here, the lone pair from this oxygen will attack that bond there, and the electrons in the sigma bond from that carbon-carbon sigma bond will go over into that carbon-oxygen bond, causing this bond to break and the electrons to go into that oxygen. So this kind of forms two things here. A ketone that's produced, and then you also have a carbonyl oxide. So you might be asking why the electrons, like if the electrons from this side attack this bond here and create a sigma and a pi bond, can the electrons over here do the same thing? And yes, they can, and it would result in a different intermediate, but those intermediates will react the same way to form the same final first step product, as we'll see as I continue. To form the product of this first step, the pi orbital electrons will go up into this oxygen. These pi bond electrons will attack here. These electrons from this, sorry, I should include positives and negative charges. These electrons from this negatively charged oxygen will attack the carbon of the ketone, and it will come out to form this molecule that's also cyclo in character, as you'll see. So I have our two groups here. We'll have our oxygen, and then I'll be attacking. So this oxygen here is this oxygen here. I just kind of flipped this molecule upside down just to help better orient myself. And so this oxygen is attached to another oxygen, which is attached to a carbon, which has an H, R3, and this carbon is also attached to that oxygen because the pi bond electrons from the ketone attacked this carbon in the carbonyl oxide. You kind of form also this cyclo molecule, and this is actually called a secondary ozonide, and it's called this because this oxygen here is bonded to two carbon groups. So I basically said this is really all you need to know for like the mechanism for ozonolysis, like the electron pushing reaction for your first semester organic chemistry, because the second step reactions are quite complex. So from here, this is the completion of the first steps. So as I said before, you could either reduce it with dimethyl sulfide or oxidize it with hydrogen peroxide. And if you reduce this, you will form your ketone, your aldehyde. Let me just write that out. This makes it easier to see. Ketone, aldehyde. the products of the oxidizing second step is, of course, your ketone again, plus your carbonyl or carboxylic acid. Alright, so that kind of completes the video on ozonolysis for today. If you guys have any questions, just leave it down in the comments. I'd be happy to answer and clarify if needed. And yeah, stay tuned for more videos, guys, and thank you.